So this was 35 out of 14.3.
Big block of words.
Okay, and it was this giant block of words about periods and clocks and temperatures and all sorts of jazz, right? Out of that, I at least just copied down equations and labeled stuff, right? Okay, so we've got some t that's a period in seconds. Really what I care about is that that's how the clock keeps time, right? That's where seconds are going to come into play. And then it's 2 pi, which is constant, right? And then it's the square root of some length over gravity. Gravity is also probably constant, right? Okay, so the length is the thing that's going to be changing here, and the length is given by some formula L naught, which is just going to be what they set it to at the beginning, times all of 1 plus alpha's some constant, right? Times T minus T naught, where T naught's the starting temperature. And I'm supposed to figure out if I change T naught to, or T to T naught plus delta T, how does the time change, right? You guys all see this?
Delta T. So that
I would
plug
so
in and take the derivative.
This delta T is a temperature, right? So I'm wondering if I change the temperature a little bit, how much time is gained or lost by this clock, right? So really all I need to do is what? I want to know dt, d
Little
t, right? Like that's really kind of the thing I'm looking for. Is that right? Of course, this thing depends on way more variables than that, right? So this is really wrong. I can't do dt. Doesn't make any sense because this capital T thing depends on more variables than this little t temperature, right?
So you do d over big T over dl, and then you have to do dl over little t.
Oh yeah, we could think about this in terms of a chain rule. My problem is I've got this function t, right? What does t take? Well, it takes l's, right?
Well, once we plug everything,
L takes
everything in.
L naughts
You still
and
have L naught out front.
t's.
Well,
Yeah.
L naught's a constant.
Oh yeah, L naught's a constant, right? Really, this thing only takes t? Maybe I can just take dt.
If you plug in the thing, it should work.
You guys see that? But I have to do it with the chain rule. So this should be dt d L and then
GLDT.
dl dt.
That whole jazz.
Perfect. So calculate away,
Right.
right? Okay, so should we do this for funsies? Doesn't seem that bad. Okay, so what's dt dl?
It's
L over G raised to the 1
Pi times.
pi.
Okay, and let's see. So I've got
G or G over L.
Yeah, you can take off the 2 because you're
Yeah,
multiplying
you pull down a
that.
half regardless.
okay, good,
And then it'll be L over G raised to the negative 1/2.
good.
So pi over.
Yeah. Okay, so I got pi over the square root of L over G. Okay, cool. Next thing. I need dl dt. What's that?
Wouldn't we need to take the derivative of L over G? And slap it on another 1 over G?
Ah. Do you guys all see that? We dorked the chain rule.
Yeah.
So we need a what now?
1 over G.
Perfect. You guys see that? And the derivative of the inside here. Okay. Good. Excellent. And then we could do a little simplifying actually. Let's leave it where it is for now and then we'll deal with it later. All right, so how about dl over dt?
Can we change t minus t naught to delta t?
I feel like this would be a lot easier if we distributed it. So this thing is L naught plus L naught times alpha times t minus t naught, right? Okay. Yeah, we could even go a bit further. This is really a line in t's though, right?
Yeah.
Okay, see that? It's got a bunch of parameters, but it's just a line in t. So what's the slope of the tangent line to a line in t?
L naught alpha.
Yeah, it's whatever the slope of this thing is, which is just L naught alpha. Okay, so now I want to multiply,
Yep.
right? Okay, so this should be pi over the square root of L over G times 1 over G times L naught alpha. Where the hell did all the t's go?
They were differentiated.
We have to plug in the L equation for L.
Yeah, that's probably a good idea. You guys all see that? There's an equation for L that's got t's in it, right? That's really where this dependence on t is coming from, right? So really I should rephrase this thing as, let's see, what's on top here?
Can we simplify that before we plug it in?
It's pretty simple already. It's just pi L naught alpha over G square root.
Is that what you're wanting to do?
And then I guess if you whatever you rationalize it,
How about this?
then I guess
On top at least I've got L naught pi alpha, right?
Yeah.
And on the bottom I've got the square root of L times G over the square root of G.
Good enough.
Cool. What's the square root of, or what's G divided by the square root of G?
Square root of G.
Square root of G. Okay, so I can nix this part on the bottom even,
Yeah. Just do root
and
LG.
just do root G, or root LG. Okay, great. Now what?
Now we plug in.
Okay, substitute L in. So this is L naught pi alpha over the square root of what? All that junk.
Yep.
Okay, L naught times 1 plus alpha t minus t naught. And then I forgot a square root of G. Okay, so I was wandering through all this. What was I looking for?
That.
That?
How many seconds gained or lost? How many seconds a day does the clock gain or lose when the temperature is at T naught plus delta T?
Okay, so this is the derivative in t, right? You guys all see that? I want to know about delta t, right? You guys see that? So delta t should be about what?
T minus T naught.
That.
Okay, it should be the
Times-
rate of change in the t direction, right? So that's dt dt
Times the change in.
times the change in t, right? So I do need to do one more thing, which is to say, where am I changing this, right? Okay, see that? This slope should be a constant. I remember that from doing planes yesterday. This slope, as I've written it, is not constant in t's, right?
No.
So I really need a evaluated where, like when are you making this change? I'm trying to change from t naught to t naught plus delta t, right? You guys see that?
Yeah.
So T naught's where I'm trying to take this derivative. You guys see that? So I really want to evaluate this sucker at T naught. Which is going to make my life a little bit easier because some of that crap's going to zero out on me. And you guys didn't notice, but I forgot a parenthesis in there. That was such a tangled mess. Alright, so what I should get here is, let's see,
T naught minus T naught.
I've got L0 pi alpha, right, over, and when I plug in T naught, what do you get out of that?
Zeros.
You get 0 here,
So 0, which is
So
1 plus
0
0,
there.
so you get square root L naught. So we can just put square
so I
root L
really
naught
don't
on
need
top.
any of this stuff.
Square root of L naught.
So I've got square root of L naught, square root of G,
Times delta T.
times delta T. There's your approximate change in seconds.
So it says show that this gain or loss is independent of L naught.
Don't tell me that, because it doesn't look like it is, which means we screwed up somewhere.
Well, don't you have L naught over
Well,
square root
L
of
naught's a
naught?
constant, so it
Ye-
would depend on the change in temperature.
So it probably should have canceled. So let's go find where we lost an L naught.
Well, it's where that square root of G it was.
Bloody.
Were we not? It seemed like an improper division, where there's square root of L, G divided by square root of G. Up. To the right. That was just.
All right. Having looked at the solutions manual and straightened out our error is literally this. This thing here is the square root of L naught on top, right?
Mm-hmm.
You see that?
Right.
Okay, so my result here, my change in time, right, is pi alpha delta t over the square root of G over L naught. Let me put that freaking thing in the top. It's this times the square root of L naught over G.
Square root G.
You guys with me on that?
Mm-hmm.
Like just combining this stuff and the square root of G. And then the really dumb thing that we should have noticed is that the square root of L naught over G is the period that you started with.
Over pi. Oh,
No, it
T
becomes
naught.
whatever the period was to start with. So this becomes something that your book is, like in the solutions manual, they call this T naught. Because it doesn't depend on that initial length, it does depend on how long that initial period was. Which is a really stupid way of saying it does depend on the initial length. You guys see that?
But
So
it
there's
doesn't
a-
change more depending on what length you choose.
Depending on what the period was of the clock to begin with.
Yeah.
They're splitting hairs with their semantics in there. Right?
So we
Because
were
it does
right.
kind of depend on L naught. It just depends on L naught if you look at, or it doesn't depend on L naught if you look at the square root of L naught over G as the initial period. Cool? So we were totally right. They're just weird wording.
So would that be T naught over 2 pi?
Oh yeah, we could throw in a 2 or something. Let's see. So yeah, if I plug in kind of T at time, T initially, right?
Yeah.
This piece is going to be L naught. So I guess this is, yeah, not quite T naught, but close.
Okay.
It's some constant multiple of T naught.
Cool.
Cool?
Bogus, but cool.
Yeah, totally bogus.